Hello students, welcome back to Chemical Kinetics. In this module, we will understand instantaneous rate of reaction. We will also see how to determine this instantaneous rate with the help of a graph. In the previous module, where we had seen average rate of reaction, we had taken an example where there was a road, a highway, and on that there was a vehicle. This vehicle wanted to travel from point A to D, and while making this journey, the speed or velocity of this automobile was not constant. It kept on changing. But here, if I was to point out a specific instant like that one, if I were to point out this instant, and if I were to ask you to calculate the instantaneous speed of this vehicle at that point, would you say it is the overall change in position from A to D upon overall time taken? Of course, no, because that overall change in position upon overall time taken will give you average rate over the definite interval, but not at that particular instant. For calculating instantaneous rate, what we can try and do is we can try and reduce the interval between A and D, and we should slightly try to approach that instant. For example, this is our interval between A and D. If we reduce this interval, this is what it looks like. Now I am in a much better position to identify the instantaneous rate. But wait, not yet. Look at this. If I close down, if I narrow down the difference even further, now I am in even better position to say what was the instantaneous rate. But wait, look at this. Whoa, now here the interval is almost zero. It tends to zero. So I can say the small change in position upon the small amount of time which was taken for that change. This will give me the instantaneous rate, the instantaneous speed of the vehicle. If I apply the same idea to the graphical representation of average rate, I'm sure you remember this graph from average rate. What we had done in the previous module was between T1 and T2, we had drawn a line and we had calculated the slope of this line with this formula, R2 minus R1 upon T2 minus T1. This gave us the average rate. Now what I will do is, since I have to find the instantaneous rate, I will reduce the interval just like the previous example. And while I do that, while I reduce this interval, you will see that as the interval narrows down, the line slowly approaches the curve of the graph. Look at this now. The interval has reduced even further, and now we are almost there along the curve of the graph. Since we have to find the instantaneous rate of reaction at this point right here, the difference is now so small that it tends to zero. What you are essentially doing over here is you are drawing a tangent at point P and calculating its slope. So basically, instantaneous rate is the same as average rate, just that your interval is so small it tends to zero. So basically, you apply a limit to the earlier formula. That's it. It's the same as average rate, just your interval is way too small. Once again, so that I can reiterate this across to you, if you have a graph of concentration of reactants versus time, at any point of time, say at point P, if I want to find instantaneous rate, since the difference taken will be really small, the concentration will be very small, the difference in time will be very small. So what I'm really doing is I'm drawing a tangent at point P and calculating its slope. For calculating the slope, all you have to do is drop a perpendicular from point A, carry on all the way down till point B, and make a right angle triangle till point C. This AB upon BC will give you the slope of the line. So let us try and understand instantaneous rate with the help of a definition. So far we know that the rate of a reaction at a specific instant is called as instantaneous rate. The definition will be something like this: the change in concentration measured over an infinitesimally small time span is called as instantaneous rate. So essentially it is the same as average rate, just that your time span is infinitesimally small. It will be the same definition with a limit applied to the time interval. In fact, if you are given a reaction like this one right here, PCl5 is giving you PCl3 and Cl2, your rate of reaction will have the same equation, just the interval will be very small. So it will be minus D concentration of PCl5 upon dt, where D represents an infinitesimally small change. Delta represented a big change. So essentially, I'm not changing the equation. It's just the terminology which indicates the magnitude of change. So the rate can also be written as D PCl3 concentration upon dt or D Cl2 concentration upon dt. So it's the same thing, just that your change is really very small. That's the difference between instantaneous and average rate. Average rate is measured over a definite interval of time, and in that interval, if you take an infinitesimally small interval, it will give you the instantaneous rate. That's all for this module. See you in the next module. Thank you.